Am I audible, guys? Are you able to hear me?
Yes, sir.
So let me just share the screen meanwhile. And I'd like to ask you guys that what is the notion you came here? What expectation do you have from this? Can you guys let me know? Anyone? Yes, you have to speak.
Brief intro to the USB protocol.
Okay. And that you will get somewhat. And what about others? See, since this is a protocol, it should be discussion. It shouldn't be like one-way communication. Before moving into USB, you need to know what exactly is a protocol. And somebody asked the duration. It will be difficult for me to look
Hello,
into it.
sir.
It's better to unmute and talk. How the course will go for entire duration for a month. Yes, somebody was speaking.
Sir, already we have so many serial protocols like PCIe and Ethernet SPI like this now.
Mhm.
Why again we are going for USB especially? What the futures and how the industry level we are going with the USB? That is what
Yes,
we are
very good
expecting.
question. Why USB? Let me first clarify that what we'll be doing in this session. First of all, there is a prerequisite. The prerequisite is you should know system Verilog and UVM. I don't have to teach you that. And one on-chip protocol. It can be APB or AXI or AHB or Wishbone or whatever it is. You should have the idea of an on-chip protocol in order to understand. This prerequisite is must. Okay. Second thing is the duration. It will be around 1 month if we have regular classes for 5 days, 5 to 4 days, 1 hour session. Mostly discussion will complete it in 15 to 20 days. And third, we won't be designing or writing a verification environment of the USB core. We'll be doing it for the file. I'll tell you what it is, but this is what the crux of it. And now the demonstration is just the overview of what we'll be doing. First thing. Second thing is what can you expect from this session. Third, third thing is a brief, as somebody mentioned, brief about USB, and let's say why USB. I'll cover some portion of it, but not the entire. Any other question you guys have in your mind regarding all of this, whatever I have just mentioned? Please, guys, you have to speak up.
Hello, sir. Third point is like a file layer, right?
Yes, there are two
Yeah,
file
yeah.
layers. Yeah,
We have seven layers. In that, the last layer is physical layer, right?
7 layer. Where is 7 layer OSI model you're
Ah,
talking
in
about?
OSI model. USB also having layers,
Yes,
layer structure.
USB is a layered based protocol. USB 2.0 has two layers, MAC layer and a file layer. USB 3.0 has protocol layer, memory layer, physical layer. And we
Okay,
will be
sir.
doing only USB 2.0, not 3.x, not in this session, not in this course. That will be a different advanced version of it. We'll be looking into from USB 1.0 till 2.0. We'll be understanding USB 2.0 plus FSMHS. Any other query?
Then you also explained the differences between 1.0 and 2.0 of
We
US.
will understand the difference from 1.0 till 4. Theory portion will be covered somewhat different,
Okay, okay,
but
sir.
deep dive we will do for 2.0. What exactly is the layers, what is the protocol, how do you interface, what are hubs, what is device, what is host, like how do you plug and play, what exactly happens, how many address, how for a single port, how many devices you can connect, what is reset, what is suspend, what is wake up scenarios, and pin configuration. If you see your USB, that's only just 4 pins. One is VCC, one is ground, one is data plus, and one is data minus. We'll see this in today's session. Any other query apart from this?
Sir, uh, do you cover all the features like in the sequence in developing the test bench, like power up and suspense resume?
No, not the test bench of the core will not be doing it in this. That is the second. There are two parts of this course. This is the first part where we'll see only the five.
Okay.
The core portion of it, core can either be host or device. It is difficult to get hold of this RTL, but you will get the device portion of it. We'll verify it. The test bench will behave as a host, and then we will connect this hook into this device. That we'll do in the second portion of it, not in this course. No, we'll use here UTMI interface and connect the PHY with it. This we will verify.
So UTMI is only having packets, right? So packets have generate means have a multiple scenarios, bulk, IC,
That
ISO,
we will
ISO.
write. That we will write as a constraint. That we'll write at a test bench. That will provide it to our PHY. It will convert that packet into pin level, serialize it, send it across. That we'll see whether it is doing it correctly or not. I'll come back to this in a more detailed way. I have a slide for this. What we'll be doing exactly.
Okay, okay. Thank you.
Anything else? Any other query apart from this? No query? First thing is what?
Is the demo recording will be available?
Yes, that will be provided. Okay. First thing is what exactly is a protocol? Can you guys tell me?
Set of rules.
Set of rules. How many type of protocol we have?
Two types of protocol.
What are those?
We have on-chip protocols and serial protocols.
On chip or off chip you can
On-chip
call.
like
You can call peripheral. Off chip or peripheral. Okay.
peripheral.
Hmm. What we have in on chip?
AMBA protocols, APB,
Amba protocol.
AXP.
AMBA houses a lot of protocol: APB, AHB, AXI, and then apart from AMBA,
ASP.
what we have?
ACE.
Those are all the cache coherency. There's open source as well, Wishbone, OCP. There are a couple of those. Now, what exactly we have in off chip?
SPI.
SPI, I2C, I3C, PCI, USB, Ethernet.
The first question, let's say as a system architect, I want to as you guys mentioned, whatever it is, it's already written here. So these all protocol we have, serial and parallel. Let's say these are all types of protocol I have. First of all is this main thing, which one I'll choose. Let's say if it is an SoC, system on chip, we have a CPU, we have a GPU, we have some IOs, GPIOs, general purpose input output, some NPU and then RAM. How do you communicate between these two? This is all. We use on chip protocol, right? What do you mean by peripheral and off chip? Let's say there are two, your controller and a sensor. How do you communicate? Let's say this is a temperature sensor and this is a controller. How do you communicate? You communicate through off chip. Now what to decide, which protocol to choose, why we will choose AXI here, why we'll choose when you connect IO we'll choose APB here. It depends on what?
It depends on frequency and bandwidth.
Frequency and bandwidth and
And performance.
PPA, power, performance, area, right? We need less power, we need more performance, we need less area. So based on this trade-off, we decide which protocol to choose. Similarly, there are two sets of protocol for off-chip, low speed and high speed. Let's say there is a sensor. Do I need to connect a PCI here? PCI 8 gig, let's say USB your 2.0 480 Mbps. Do I need this kind of speed and logic to connect a simple sensor, which will your every second it will tell me the latency of this is every second. Do I need a high speed protocol here in this scenario? Yes guys, tell me. A simple
No.
sensor, let's say I want to transfer a movie from one drive to my PC or some other drive. Can I use a serial protocol? Can I use a low speed peripheral where the speed is in some kbs? Will you use that, or will you use some high speed protocol where you will copy, let's say 1 GB of file in within few minutes? Which one will choose? It depends on the use case scenario what you will choose. Now in between this PCI, SATA, DDR, USB, why USB? USB is hot pluggable. That is the major difference from USB to PCIe is that for PCIe you connect GPUs. So if you want to connect an external or the what you say new GPU set of GPUs on your motherboard, you have to turn off your system and then again plug in your GPU, then turn on, then it will do your enumeration and your speed negotiation and device detection. Whereas USB is hot pluggable. You just connect and you can disconnect it. It won't affect. It has a built-in feature of hot pluggable. Now, I'll give you some history. Any questions you guys have here? How many number of pins we required? If you see earlier computer, what, how many ports you guys have? We have PS2 to connect the mouse. We have your RS232 to connect our monitor. We have eSATA to connect our drives. We have this composite for our audio and video. We have this display port and DVI port to connect our your monitors. Now, let's say if I am your PC manufacturer and I am a peripheral designer. Let's say my PC supports 7 peripherals. These are all peripherals, and I'm a port, and I'm a peripheral guy that I'll design a monitor, I'll design a keyboard, I'll design a mouse. Now it is very difficult that uh, OEM or a manufacturer pack all of this port. There should be a trade-off. Now they used to think like, okay, what we should put into a system. There are so many ports. We can't support all the ports. So there comes the picture of a universal serial bus. Let's say all of this connection, whatever you have, we should have a common your serial bus in which your port manufacturer and your OEMs, the device manufacturer or the system manufacturer, they can be aligned, and we don't have all of these ports messing around. Understood the idea why we need USB? It's very simple. If you see how many ports we have, how many pins we have, it's a simple port. How many pins we have for USB 2.0? If you see, this is the type A, there are different connections and different ports. We learn that in the session, but not here. Basically, there are 4 pins: VCC, ground, this is data plus and data minus. Okay. If you want to see what colors the pins are, you can see your data minus is white, data plus is green to indicate. Now what we'll do in this session. So this is what we have, the USB, and we have 2 pins, data plus and data minus. Now based on this data plus and data minus, this is a single pin, means it can have either 0 or 1, means if it is 0 volts, means let's say it is 0, if it is 5 volts, means it is 1, right? Let's say if I change like this, and this is differential, and something like this. Now based on this position of D plus and D minus, we have certain symbols. Now if D plus is low, D minus is high, we call it as a K state or K symbol. When D plus is high, D minus is low, we call it as a J state. Call it as a K. This is K. When both are 0, 0, we call it as a SE0. When both are high, we call it as a SE1. Basically, we communicate with only these 4 symbols. From this 0 and 1, we'll formulate a packet structure with number of bytes, and this bytes will go to high level, that we'll call it as a transfer, and this transfer is initiated by the core. The core is basically either a host or either a device. Now host is our PC or laptop. Device can be our mouse, keyboard, and what else? Printer, webcam. Okay. Any questions here?
Can you say the middle part again, sir?
Which middle part?
These one, these boxes you see.
See. So first of all, that what we have, will transfer in bits: 0 1 1 0 1 0 1 0 1 0 1. Now how do you get into this 0 1? Based on the states, based on the change in D plus and D minus. This is your 0, this is your 0. We use NRZI encoding scheme. Why we are doing that, we'll see that in the session. And basically this state represents the values. This is the value of the bits. Now what this bit indicate will fragment it into bytes, multiple bytes. Let's say this is sync, this is my PID, this is my address. This set of bits represent this, and collection of this is known as a transfer. We have control transfer, bulk, interrupt, and ISOC. 4 transfers we have. And then how we'll initiate a transfer? The core will do it. It can be either host or it can be either device. Core will issue a transfer, send it to the PHY. PHY will serialize it and send it to D plus and D minus. But this will come from our core. Now when to do what transfer? When to do what transfer? What, let's say I have 1 GB of movie in my hard drive. I want to copy and paste it in my local hard drive or my PC. So there should be some negotiation. That negotiation should be done by the core. Where is this location file present? That will be that instruction you will get it from the upper layer. The upper layer is your software. We'll see how the software interacts with the code. That is in chapter 9 of the spec. So basically the spec is 650 pages, but we have distributed and broken down into multiple layers. Any questions here? We'll go deep dive into this. If you want to see the waveform, let me show it to you. Now how do you interpret what it is? We'll see how to get this sync. We'll see this as a setup token, how to understand whether this is a setup token or not. What is the address, endpoint, CRC, and this EOP. This EOP and sync will be added by the file, and this we will generate from our TB. This will be very small portion, only 10%. Whatever we do, 10% of the entire session. 90% will be your most of the understanding of how a USB works, how a layered based protocol works, why we have all of this packet structure. Is that clear?
Sir, we are going to learn some complete all 3 layers, all
No,
layers,
no,
or
no,
just
no.
physical
3
layers?
layers is not present in 2.0.
2 layers, data link
2.0,
layer and physical layer is then.
we have just MAC layer, and file layer is UTMI. This is a file. So we'll see the signal description of UTMI. We won't go with the implementation of UTMI. We'll understand the entire MAC layer of 2.0. Let's say whenever you connect a device, what exactly happens? We'll have device detection. We'll detect the device, right? What kind of
Yes,
device it is.
due
There are 3
and
types of device:
enumeration.
LS, FS, and HS. Second thing, after device detection, what you will do? Speed,
Enumeration.
speed negotiation.
Yes, yes, speed negotiation.
Third is enumeration. In enumeration, what are the other subtypes of enumeration? We'll have address. We'll assign the unique address. We'll get the descriptors. Once what kind of device it is, right?
Yes, yes.
And then we'll do the transfer. Now this all enumeration and all happens with the control transfer, and we'll also see. Let's say you came up with that, right? Wait, let me show it to you. This one. These all high level abstract what the USB controller will do. This is converted into signal level bits for more understanding. And for better understanding, there is a pulse view. Let me show it to you. This is the waveform dump, which has your TX data plus and data minus, RX data plus and data minus. And this is a simple USB analyzer signal. This is TX coming from the transmitter side. This is RX coming from the receiver side. So if you just zoom in, if you see, first is reset. Let's say I'll zoom in. See, it says this is an ACK, it says this is setup address. I have received the ACK for this guy, right? This is for better visualization if you want to visualize it, because it is very difficult to debug in the waveform like this. So you need some assistance. This is SOF start of frame, and yeah, this is my ACK, this is my start of frame, this is the address. So if you see what in the waveform you saw kj, right? And what is this d plus and d minus, whatever I was showing. Since this is tx, you see this data plus and data minus. Data plus is d plus and this is d minus. If you see it is k, see data plus is your 0, data minus is 1. If it is j, data plus is high, data minus is low. So this signal you see in the USB, that is interpreted as kj, and this sequence is a byte. At that byte we'll get to know, okay, this is a sync which is coming from the file. So next set of 8 bit is my PID. So PID will decide what is the next set of bits. So next set of bits, since this is in token PID, token will follow address and then endpoint and then CRC5. So we'll do CRC5 on a piece of paper, how to calculate CRC5 for a USB, how to calculate CRC16 for a USB. So mostly this session will have 70 to 80% of theory and understanding of this, and 10 to 20% of your coding of the file test bench, not the RTL. Understood? Did I made it clear?
Yeah, yes, sir.